So we're going to talk about that. I've got three components to our overall, if I get this to move forward, there we go. So we're going to take a look at what happened last year. Lots of very significant weather, but I'll go through that. And, it hasn't stopped. Take a look at what's been going on so far this year. And then the why all of this seemingly extreme weather. And then I'll give you a look at the outlook for the rest of this year from your perspective in supporting your local emergency management community with regards to whatever Mother Nature may provide us coming ahead to the rest of this year. So let's take a look at this past year's weather. And, it was, I'm going to let James Taylor kind of bring that up here in just a 3 or 4 second clip.
Oh, I've seen fire and I've seen rain.
And that was the summary of 2021's weather, the year of fire and rain. Let's take a look at the moisture first. Lots of it. Just in the month of July alone, you might remember not one, but two significant heavy rain events and European flood. You see an image here in the upper right reflecting the amount of urban flooding in Belgium and in Germany. Later that same month, another very similar kind of event resulted in flooding and urban flooding in central China. Just a month later, another heavy rain event in the middle of the U.S. with significant flooding in middle Tennessee. And late in the month, as Hurricane Ida came ashore, significant rainfall, storm surge, and flooding that occurred in Louisiana. Now, that storm was not done yet. It continued to the northeast, and the remnants of Ida there in early September dumped a lot of rain in extreme southern New York and a good chunk of New Jersey. You see a ballpark there that is totally underwater. And you might remember that there was a lot of urban flooding with basement, apartments. People couldn't get out of their apartments with the pressure of the water on their doors, etc., and some unfortunate fatalities involved with that as well. Going on into the month of November, this one's local. You might remember it was just a year ago that we had heavy rainfall from an atmospheric river, very much like what's going on as we speak at this moment for the next 36 hours or so. But it resulted in significant flooding in Whatcom and Skagit counties. Many of those areas are still recovering as we speak. Now, moving over to the fire side. So we go from one extreme to another. Been very dry. I'll show you some images on that here shortly with regards to much of the western U.S. Some big fires in 2021. The bootleg fire in south central and southeastern Oregon, about 500,000 acres. You might remember the Dixie Fire in the Central Sierras, including burning down the town of Greenville, depicted here on the right. Here in Washington State, our most significant wildfire was the Snyder Springs Fire east of Mount Rainier in the Natchez Basin. And as a result of the hundreds of fires across the western U.S., we had smoke carry all the way across the rest of the U.S. through the central and eastern parts of the U.S. And we could go on and on with regards to the worldwide examples of wildfires that occurred in Greece and Australia, France, Siberia. In fact, we had our share of wildfire smoke from Siberia before we got into our own wildfires itself. And at the end of the year, you might remember these two significant weather events. Again, it was very dry and quite warm in the Central Rockies. And as a result, they had a wind-driven wildfire that burned over 1,000 residential homes there in Boulder County, Colorado. And just a week later, the Mississippi Valley tornadoes, including those in Kentucky and Tennessee, wiping out a number of structures and towns, literally. Well, it wasn't over here as we headed into 2022. Like the mid-Tennessee flooding, another heavy rain event and the flooding there in Kentucky. Hurricane Ian moved ashore in Florida and then re-energized and moving on shore into the Carolinas just a few days later. Again, with our heat and drought and wildfire situation, the McKinney fire, which was in extreme northern California, just one example of many other fires that we had in the western U.S. this year. And as a result, we had our share of air quality issues. For our region, this was our fifth out of the last 6 years with wildfire smoke here in the Puget Sound area. And this one was by far the longest stretch, starting with the Bull Creek fire on Saturday, September 10th. It took until October 21st to finally get rid of all of the wildfire smoke when our fall rains finally arrived. And speaking of that, this was unique. You remember that our spring was very cool and wet. And literally, the spigot was turned off on the summer solstice, June 21st, and the spigot was turned back on again on October the 21st. SeaTac Airport had just 0.54 inches of rain, so very dry conditions. It was the driest ever on record. And that resulted in a lot of our wildfires throughout the region, including the Bull Creek, but there were many others involved in the situation as well. And now we're back to the rains at this point, so stay tuned on that. So why is all of this happening? Well, these are literally fingerprints of a warming planet. So this particular research oceanographer analyzed global temperatures from the 1950s through the first decade or so of this century. And the screaming message out of all of this is that our summers are longer and the other seasons are shorter. How much longer? Looking at that data, the length of summer, this is globally now, not just here locally, although we kind of had an extended summer this year, didn't we? Has increased by a little over 4 days per decade, extending out now to 95 days. And obviously, the other seasons had to get shorter. And you can see, I won't go through the details here, but you can see winter, spring, and fall have all decreased in the length of their seasons around the globe. In addition, all seasons, summer, winter, spring, fall, were all warmer. And the 2010, so after this research oceanographer, Yuping Guan, had looked at the data, the 2010s were the warmest ever recorded, continuing this seasonal trend that we have been witnessing during our lifetimes. Get this to move forward. There we go. Now, speaking of that, let's take a look at the annual temperatures across the country compared to the 20th century average. And if you go back to the beginning of the 20th century to the start of this new century, the trend is pretty obvious, where we get into the 30-year average of 1981 and 2010, and the most recent 30-year average, 1991 to 2020, a dramatic difference from average moving through the 20th century into the 21st century. I mentioned new 30-year averages that came on board in the May of last year. And what you see depicted here is the difference between the previous 30-year averages from 1981 to 2010 to 1991 to 2020. On the left-hand side is the annual mean temperature change from those two 30-year averages. And on the right-hand side, the difference in annual precipitation. You can see much of the western U.S., particularly the Southwest, much drier, whereas east of the Rockies, from Montana to New England and Florida, tended to be a lot wetter. Now, I brought this up earlier. We've kind of seen some evolving weather patterns resulting in our longer summers and our longer wildfire seasons. On the left is the U.S. Drought Monitor from early July of 2011. And now look to the right, 10 years later, how much drier the western U.S. is now compared to what it was 10 years ago, a decade ago. And you can see across Texas and the Southeast, you might remember when Atlanta was running short of drinking water here a decade or so ago. That is not the case today. So, continuing on with why, our warmer air around the globe can hold more moisture. In fact, studies have shown it's holding about 10% moisture than it did roughly 100 years ago. So, the same kind of storm now has more moisture involved with it. And so, in the same amount of time, it is dumping more rain, which is resulting in all these flooding and flash flood events we've witnessed around the globe, not just alone here in the country. The classic phrase, what goes up must come back down. So one of my colleagues with the National Disaster Preparedness Training Center is Doug Stoltz. He came up with this nice quote that I think really helps explain it. And it goes into more of our higher amplitude weather patterns, such as our heat dome from last year. So he says, not only are we experiencing the reality of the warmer atmosphere holding more moisture, but also shifts in when and where the moisture is deposited. And we are seeing a higher frequency of jet stream blocking events, which is why we had the really extended summer this year, for instance, and increases in the magnitude of flash flooding and the associated rain rate with those, and the expansion of drought conditions. So looking at one significant blocking pattern, this was our heat dome from late June last year. The jet stream is depicted in the blue, and it wrapped around in kind of an omega-shaped pattern that became very stable and literally fed upon itself and resulted in the dramatic warming that we witnessed not only aloft but here at the surface as well. I won't go into all the details on here, but the bottom line is you had descending air, and that helps compress it, releasing more heat, and that's why we had temperatures easily crack the century mark there in late June last year. In addition, if you look at the blue line on the right side, you have kind of a northerly pattern going from Canada down in towards Texas. This is the same kind of pattern that resulted in the Texas February 2021 cold wave, and all the snow and ice and the power grid issues that the Lone Star State had during that type of that time period, I should say. So more on why all of this is resulting in warming oceans. So on the left here, you see a depiction going back to the 1960s and up through 2016. It's the latest chart I could find on this, but it tells the story. You can see then the Atlantic, the Caribbean, much warmer sea surface temperatures now than it was, 45 years ago. Even in the Pacific, you see a considerable amount of warming, as well as, south and west of Australia and up into the Indian Ocean. Remember, our air can hold a lot more moisture, and now it's being fed by a warmer ocean as well. And as a result, our hurricane season, you might remember 2020, we had a record 30 named storms in the Atlantic, and it went deep into the Greek alphabet. Well, the World Meteorological Organization said, let's not do that again. They've now come up with a backup name list in case we ever run into that. And last year, we got close to knocking on the door for that. There were 20 named storms, with Wanda ending up there in November as the last one. They don't use the letters X and Y and Z, just to give you an example. So they use 20 out of the 26 letters in the alphabet. And this year, we've had 9 thus far, and I really should update this because the 10th one was just named yesterday. But here we are towards the end of the hurricane season at this particular point. We're pretty close to it. So those warming oceans, well, there's several things that happen as a result of it. Number one is rising sea levels, and it's driven by several factors. Number one, thermal expansion of seawater. For instance, if you took a mug of water, put it in your microwave, and heat it up for, say, 1 or 2 minutes. Note how much higher the water level is in your mug compared to what it was when you started. That is an example of thermal expansion of what's going on in the overall seas around the world. In addition, a lot more water is being dumped into the oceans as a result of ice melting, whether it's from glaciers or from Greenland, the polar regions, all of the above. And then you throw in any kind of storms or anything like that, and then you can get, it's much easier to get coastal flooding. And the picture in the lower left, this is a sunny day in coastal Florida. And during the high tide cycle, the water is now moving into low-lying areas, such as this particular stretch of Florida City, resulting in what's called sunny day flooding. And I've got a link here if anybody wants to write it down or maybe take a picture of it so you can share it amongst yourselves. I won't play it here in the interest of time. But it is not only just in the oceans, but also in the Great Lakes and the impacts of rising waters in the Great Lakes. Well, all of these big storms, we've just seen a dramatic rise in the number of billion-dollar storms. This chart goes back to 1980, but the general trend is definitely on the rise as we move through into the 21st century. And in 2020, there were 22 billion-dollar storms for a total of just over $100 billion. Last year, there were 20 of them, racking up about 145 billion. And so far this year, there's only been 15 billion-dollar storms, but the granddaddy of them all is Hurricane Ida that moved into Florida, and that price tag for all 15 of those is now right around $340 billion. And I hate to say it, I think they're still counting. So this is something that all of us are having to deal with regards to the increasing amount of damage that occurs with these types of storms, especially as we get more of them. In addition, and I don't have any statistics past 2016 at this point, but just a general rise in the number of major disaster declarations. And you can imagine past 2016, quite a rise with the wildfires, hurricanes, and other types of storms that have occurred in recent years. So before I move into the seasonal weather outlook, are there any questions on what has been happening and why it has occurred?
Ted, there was noticeable articles on the internet about the glaciers in Alaska and Greenland and showing huge calvings going on there. And some of that ice is hundreds of years old. Is that correct?
That is correct. I've seen those video clips as well. Another outcome, and this is part of my climate adaptation for emergency managers course from FEMA that I teach with the National Disaster Preparedness Training Center. But because of a lot of the warming, at least in the North Pole region, the permafrost is thawing, and inside that permafrost is a lot more greenhouse gases, not only carbon dioxide, but methane, which is even a more efficient greenhouse gas. So it's just kind of accelerating or adding on to the issue itself. And so, again, that's just helping to warm things up, and that's why we're seeing as much ice melting going on as we see. It would not surprise me that in the coming years, we're seeing some of it now, but you'll be able to sail across the Arctic Sea to go from the Pacific to the Atlantic. From a shipping perspective, that's a heck of a lot shorter than going through the Panama Canal or something like that. So that's one benefit out of it, but you can obviously we are all witnessing a lot of the impacts from how our planet is warming up. Hope that answers your question. Any others?
Yeah, the elephant in the room always is the warming of the planet. Is it a natural occurrence, or how much has the human factor played into accelerating it, for lack of a better term?
Again, this is a component of the climate adaptation for emergency managers course. If I had that particular segment of that course, I would show you a chart from Mauna Loa in the middle of the Pacific Ocean on the Big Island of Hawaii. There's a weather station there. It's been tracking the volume of carbon dioxide going back to the start of the industrial age. The screaming message is a steady increase in carbon dioxide out in the middle of the Pacific, nowhere near industry, cars, anything like that. It's a pretty nice spot to be measuring this, and it is a result of burning fossil fuels, basically since the start of the industrial age. So you have to say that the human element here is very, very significant.
Okay, thank you.
You bet.
Wow.
All right, are we ready for the seasonal weather outlook?
Yep.
Please.
Sounds like we are. So this is from the National Weather Service's Climate Prediction Center. Some of you have maybe seen me give these presentations in the past. A quick review of El Nino and La Nina. So El Nino is when sea surface temperatures in the eastern Pacific tropical waters, we're talking about the waters west of Peru, are warmer than average. And La Nina is when those same sea surface temperatures in the tropical waters are cooler than. And I'm assuming most of us have been to the Hawaiian Islands. This is mainly driven by the strength of the trade winds and how this occurs. So as a result of what's going on in the sea surface temperatures in the tropical waters, particularly in the eastern Pacific, it is reflected in how tropical weather occurs, and that in turn adjusts how the jet stream or the storm track behaves across the northern Pacific, let alone the rest of the globe. We're kind of focused on our neck of the woods here. So on the right-hand side, particularly in an El Nino scenario, which is what California, Nevada, Arizona, New Mexico, Colorado, they would love to get back to El Nino because the storm track spends a lot more time in their neck of the woods and provides a much wetter type of season, which they desperately need at this particular point. In our area, we tend to have a warmer than average winter season, and there's no real trend on precipitation. Some may argue that it's a little drier. Yeah, it's in the 90 to 95% bracket, nothing dramatic with regards to droughts and things like that. In the case of La Nina, all the hot water's over in the western Pacific, and so the jet stream is very strong coming out of Asia and translates and results in having the storm track spend a lot of time at our latitude, and that is what has just kicked in just the last few weeks. Every once in a while, it will buckle. Remember, we talked about more of these blocking patterns. It'll buckle, go up into Alaska, the Yukon, grab cold air and bring it south into the lower 48, including our area. So we have a tendency to have cooler and wetter winter seasons. Meanwhile, the southern tier of the U.S. Remains pretty dry, and that's kind of where we're headed for this particular winter at this time. Excuse me. So taking a look at a historical perspective on El Nino versus La Nina. El Nino are the red spikes you see there. You can see some significant ones, particularly like 1982 and 83 and 97, 98. And the La Ninas, for instance, the 1998-99 winter was the year that Mount Baker had its all-time world's record of 1,140 inches of snow during the winter season. You can see some other La Nina years depicted there, including some of our more recent winters. Also, what is the definition of a weak, a moderate, or a strong El Nino or La Nina? Because that translates into this pie chart right here. Generally speaking, neutral conditions when sea surface temperatures are pretty close to average is about a third of them, La Nina about a third, and El Nino about a third. But there are some flavors for El Nino and La Nina with regards to the strength of it. So where are we at the moment? So first on the left-hand side, during the 1980s, NOAA, the National Oceanic and Atmospheric Administration, some of you have heard me describe it as the National Organization for the Advancement of Acronyms, they installed a suite of buoys from Peru all the way across the equatorial Pacific, and to help kind of measure this phenomenon that is the El Nino and Southern Oscillation. And they found this geographic hybrid area, Nino 3.4, to have the strongest correlation to how our weather during the winter season behaves. On the right-hand side, I just updated this over the weekend, but going back to this time last year, you can see that Nino 3.4, in fact, all of them for that matter, have been cooler than average, for the past year. And if we went back even further, it would remain that to be the case as well. So here's our current tropical Pacific status. In the upper right is observed sea surface temperatures. In the lower right are those temperature anomalies. And you can see a lot of blue depicted there across in the equatorial Pacific region, especially the central and eastern Pacific. So it's anticipated that La Nina conditions are going to remain in place for the third year in a row. That's only happened one other time, and that occurred in the mid-1970s. So La Nina is anticipated for this winter. That means our jet stream or the storm track is going to spend a lot of time in our neck of the woods. And La Nina winters historically produce more snow in the Pacific Northwest, both in the mountains and in the lowlands. I'll go into details on that here in just a moment. Started a little animation that kind of shows the trend going back into August. And you can just see that there's a lot of blue being depicted there and working its way westward as well. Again, this is a result of the trade winds being stronger than they normally would be. Now, somebody's going to ask, well, why are they stronger? That is the chicken or the egg question. Do not have the answer to that at this point. All right, so what's ahead? This particular chart here shows a whole suite of forecast models of what that sea surface temperatures are going to be in the Eastern Pacific tropical waters. And I'll overlay what the La Nina, neutral, and El Nino looks like there. But in the winter season, here we've got excellent chances for La Nina conditions, better than 70% chance. As we head into spring, by the time we get to like April, May, and June, things are trending towards neutral conditions at that point. Another way to look at it is this particular chart. La Nina is blue, El Nino red, neutral in the gray. And the far left-hand side, OND, stands for October, November, December. Next to it is November, December, January. I think you get the idea. So La Nina, quite strong right now, has a tendency to weaken as we move through the rest of the winter season and make that transition more to neutral conditions. I will point out, last year, this was the trend heading into this year with regards to transitioning to neutral conditions. Didn't really pan out real well. So looking at the winter season from December through February, very La Nina looking charts here. I do want to point out in the upper left-hand corner, I kind of threw some poker chips in there. So I want you to think of piles of poker chips of warmer and cooler or near average, and same thing for precipitation as well. So in the lower left, you see pretty good odds, 60% chance of below average temperatures overall for the 3 months, not the entire time period. We'll have some periods where it gets more mild, but overall, the trend will be cooler than average for the time period of December through February. On precipitation, well, we've stacked up 55 out of 100 poker chips there for above average precipitation during December, January, and February. If we take that information and take a look at what it means for our big weather events that we get around here, for major floods, neutral is the number one pattern for the big floods, with La Nina a close second. And an example of that was our Whatcom and Skagit County flood event that we had just about a year ago. El Nino, a distant third with regards to major floods. For windstorms, the big ones, La Nina is number one with neutral right behind it, and El Nino, again, a bit more distant third. And for lowland snow events, La Nina definitely number one. If I had a graph chart here, it would stand out like a sore thumb. Neutral plays a role, and El Nino is actually a pretty distant third with regards to lowland snow events. And you might remember, we've had La Nina for the last 2 winters, and we've had lowland snow for the last 2 winters. So in summary, La Nina is back for a 3rd year in a row, rather rare 3rd year in a row. For the winter outlook, cooler than average temperatures, wetter than average precipitation. For those who like snow up in the mountains, maybe to play in or for water supply, whatever your concern, really good odds on a healthy mountain snowpack. You might remember a cool, wet spring last year got us up well above average by the time we got into the latter part of April and into early May. And just a reflection that the Climate Prediction Center's seasonal outlook is updated on the 3rd Thursday of each month if you wish to go in and take a peek at it as we progress through the through the winter. So some of my concerns as we head into this winter season. Number one, we saw this early on in the presentation, warmer air can hold more moisture. And we've already seen evidence of this here in recent years. For summers, well, they're going to continue this 21st century trend of warmer and drier conditions. Our summers are longer than they have been in the past, and that can lead to more excessive heat episodes and, unfortunately, more wildfires and smoke across the region. For this fall and winter, with La Nina conditions in place, well, these wet atmospheric rivers, they might have more moisture in them and result in more flooding, which is what's in the cards for the next few days. Windstorm-wise, we have not had a significant one, I mean a good one, since the Hanukkah Eve windstorm of December 06. And we usually get a strong, damaging windstorm like that about every 10 years. We are overdue. And might highlight that our snow season can begin in mid-November. You might remember November of 1985, where we had at least a half foot of snow on the ground before Thanksgiving. Not saying that's going to happen this year. Our prime month for snow is in the month of January. If I had a bell curve, that would be the case, but the front end of that bell curve would fall in the mid-November timeframe. And I know people are saying, hey, aren't we going to get a little snow next week? Well, stay tuned. I think our snow levels will be down to around 1,000 feet or so, but nothing expected down closer to sea level at this point. So that's what I have to offer for you. Just kind of a fun little wrap up here. If you're a country music fan, you might recognize this particular individual. Oh, it didn't play for me. Bear with me. Hello, Mouse. Where are you? There you are.
I'm gonna wish I had a storm warning.
All right. That's what I have for you. If you're interested in my North Sound Weather Minute podcast, the latest one I just posted last night, it discusses what is the meaning of a 100-year flood. You'll find it at everettpost.com along with a number of news articles there. And you can catch me on Twitter for those who use that social media platform at Tornado Ted 6. I am open for any questions with regards to the winter weather outlook.
So Ted, one of the things that I've proposed for everybody is NOAA weather alert radios. Can you make a comment on how valuable or how worthless they are, in your opinion?
Well, it's an amateur radio. Those are the ones you don't want on your scanner, obviously. But with regards to an all hazards alert system, it's by far number one. It can provide you with emergency alert system activations anything from weather, tsunami, and from the emergency management community's perspective, there are 17 non-weather related event codes that can be activated that way. Some examples: hazardous materials. We already know about Amber Alerts, jailbreaks, contaminated water, all these kinds of things that unfortunately can occur that are not weather related. And it can be used at home, in your car, school, healthcare facilities, places of worship, just all kinds of different places. A great holiday gift idea. It is literally a lifesaver for the cost of a pair of shoes. If you've been to my Weather Spotter programs, you heard me talk about it there, but it's still a very, very viable resource. In fact, I think I've got one right here. This happens to be from Midland Radio. And if my memory serves you right, it's about $30 at your local Walmart, also available online at midlandradio.com.
Do you happen to know if the Tote Dam failure might be one of those messages available to the weather radio?
That is correct. So let me give you an example on that. And they do exercises for that kind of scenario. So let's say the dam operators, and I'm not using the letter N at the end of that humorously, that they realize that, hey, after that little earthquake we had a few days ago, we're starting to see some cracks in the structure. This doesn't look good. Maybe we might want to let folks downstream know that, Houston, we might have a problem. So according to the plan, they would notify the National Weather Service and they would issue a flash flood watch, which would activate the emergency alert system. Interesting point here. For those who are dependent on only their smartphones, wireless emergency alerts will not activate for a flash flood watch. Sidebar on that, it won't activate for a tsunami watch either. Okay. So now let's say the folks are taking a closer look at the dam structure, the hydro project, and now we got a heavy rain event, a lot more pressure on the structure. It's looking like it might have the possibility of failing, maybe, imminent, not occurring yet. But we better let everybody downstream know, hey, it's time to head for higher ground. That would be the flash flood warning that the National Weather Service would activate. Again, receiving it on your NOAA Weather Radio receiver. And that one would get out on smartphones via the wireless emergency alerts, giving you that lead time to take action. That's the idea with the watch. That is the get ready, get prepared stage in case you need to move and move fast. And of course, the warning is imminent or occurring. I don't recall the exact timeline of how much from the time the dam breaks until it reaches Carnation. I don't remember the timeline. I don't think it's that long, probably on the scale of maybe an hour or so. So not a lot of lead time in that regard. So anyway, hopefully that answers your question.
Now, you already reviewed it, but could you do the alert, watch, and warning just one right after another to refresh everybody's memories?
Sure. So, for instance, we've just literally are going through it right now. Let's just talk about floods. So a day or so ago, the National Weather Service put out a flood potential outlook. Keyword is outlook. That is elevating the awareness that we might have the potential for flooding in a few days. Now, this morning, they changed that to, upgraded, I guess I should say, to a flood watch, which means that, this is the time to get ready, get prepared. Have we got the sandbags? Have we got the sand? If I'm in a low-lying, vulnerable area, I may be getting ready to pack up and be able to move at a moment's notice. Maybe I need to move livestock to the critter pads, things along those lines, whatever the preparedness activities are. And then finally, a flood warning means that the rivers are going to rise to at least flood stage. There are several phases of that. Minor flooding is flood stage. Moderate flooding, it depends on the stream, but it's usually a few feet higher. And major flood is a few more feet above that, and that basically means widespread inundation of low-lying areas. And then finally, record flooding, which is, topping off the big records on that. Speaking of that, on mynorthwest.com and everettpost.com, you'll find some articles with regards to some of the historic floods that have occurred, and that includes the Snoqualmie River, for instance. I've got that one on there, I think, on the list for the Snoqualmie at Carnation. So that's kind of a quick synopsis or summary of outlook, watch, and warning.
Thanks, sir.
Question, please, Roland. I was just up in the mountains hunting, and we had this storm coming in, and every one of us was looking at a different weather outlook app, and every one of them is different. What is your recommendation for the most reliable source for that we could have on our cell phones?
How many of them had iPhones?
Everybody up there did.
I'll tell you a little story behind that. I was giving a presentation at a emergency management boot camp, probably about 6 years ago now. And I was a luncheon speaker talking about new technology in the Weather Service. And we were talking about smartphones and the smartphone apps. And so I asked who in the room has got Verizon. Okay, somebody raised their hand. I said, okay, I want you to take your phone. I want you to look up the forecast for right here in Renton for tomorrow. And then, okay, who's got AT&T? Another hand went up. Same thing for you. Who's got Sprint? Sprint was around at that point. Same thing for you. And how about T-Mobile? Same thing there. So when it came time later in the presentation for them to divulge their forecast, like you just described, they were all different. They were relatively close. It was dry, but some were sunny, some were partly sunny, some were mostly cloudy. Temperatures ranged from, this is March now, ranged from 60 to 68 degrees for the same spot the next day. And that's just a 24-hour forecast. That's not very far in advance. So after that discussion, one of those, smart kids, if you wish, dug into on his iPhone where the weather app came from that came with his iPhone. And this is this one kind of threw me for a loop because I didn't know this. He dug into it. The source of it, believe it or not, was an app from Russia. That is what Apple used, apparently low bid, to have as the standard weather app on their phone. So to answer your question, I would use the following if somebody wants to put it in the chat box, mobile.weather.gov. Now, that is not technically an app as we know apps. It is a web application. It is the the phone version of the National Weather Service web page. But you can get site-specific forecasts. You can get hourly forecasts there. It's got the area forecast discussion, the radar, the satellite imagery, and more on that web application. Again, that is mobile.weather.gov.
Thank you. Yeah, it was frustrating. We were all up there. We're wondering, do we need to get out of here? Because they were predicting for next Tuesday a low of 7 degrees in Ellensburg, and we were at 6,000 feet. So we figured, okay, we're looking at 0 or below. So we all agreed, yeah, it was time. So we left today, but it varied, honest to God, it varied from a low of 7 to a low of 14 to a low of 1. It all depended on which app you were using.
They're all cold.
And a high percentage of them do not have humans involved. They are pure computer models of whatever that particular app has chosen to use. There's no humans involved in the process. So it can go out on a limb that just, with a hacksaw behind you and off you go. So, I don't I don't endorse a lot of the apps that are out there. I know they try to pitch and sell and things like that, which is fine. That's what they're in business for. But it can leave people in pretty dangerous situations, and you're describing one yourself.
Yeah, it was 16 this morning when we got up, and we're glad we made the decision to get out of there.
Yeah.
Wow.
Yeah. Well, it wasn't one above. Only missed it by 15 degrees. That's all.
So, Ted, do you anticipate we are going to see more dangerous lightning events in the Northwest this winter?
I don't see that per se. We get thunderstorms year round, and we get two peaks, one in the spring, one in the fall, during our transitions from summer to winter and back and forth. No, I mean, it's not to say that you don't get lightning, but we don't get very much lightning here compared to the rest of the country. Orlando, Florida, if you've ever been to Disney World, ask them if you can visit their emergency management facility. It is dramatic there. They take care of their people and their customers, obviously. Their lightning detection system is just fantastic because Orlando is number one in the U.S. with about 100 thunderstorms per year. That's pretty close to one out of every 3 or 4 days. So obviously it's much more active in the summer than in the winter season.
I'd say I was going to say 90 happened in August.
Yeah, exactly. So anyway, I don't see lightning as being, any more intense or significant than what we've had in the past here.
Thank you. That was excellent, Ted. You didn't disappoint me again. Like I said in the beginning, 2 weather spotter classes and a couple other presentations, and all of them have been just top drawer. Thanks for doing this for us. It was great.